Alright, good morning, pop stars. Let's get popping. So you're asked to prove these two angles are congruent. We should probably take an opportunity right off the bat and really decode what that's actually asking you to do, because it's not really an obvious thing. Just for the sake of this video, let's go ahead and kind of mark preliminarily where these angles actually are. And I saw some people really struggle to kind of locate these two angles. UTS, the best way to kind of figure out where UTS is actually to follow the three-letter convention in order. In other words, start at U, trace your line over to T, and then bring it back up to S. So the angle that you surpass is the angle in question. So we're trying to prove that this angle, which I've just marked in purple, is congruent to VRQ. So same thing. Let's go from V, trace up to R, then down to Q. So the other angle I've just now marked in purple, we're trying to prove the two purple angles are now congruent. So the question we should be asking ourselves is, wow, well, that's such a huge job. How in the world... Whoa. Get out of here, man, random warning. The question we should really be asking ourselves is, well, what do I actually have to prove to make this statement true? In other words, to prove it directly might be very difficult, like in one step or like in one jump. But if we can prove something else, like this auxiliary thing, and if this thing happens to be true, then well, the angles are true also. You guys did some good work in class and kind of came to an understanding that really, if I could prove the triangle that involves the angle, that would force the angle to also then be true. So what this job really is, what the decoding really should tell you, is that if I can prove this highlighted triangle is congruent to this highlighted triangle, then as a natural result of triangles being congruent, the purple angles would have to be as well. So that's really the hidden kind of thing in this proof, that we have to prove triangles are congruent, and once we prove triangles are congruent, then the two angles that we really wanted must be congruent as a result. Okay, so that's kind of the mentality we're going to take with a lot of these proofs. If you're going to be watching all four in preparation for your test on Monday, that if we prove one thing, it gives us information that we really wanted in the first place. So it's almost like a very indirect styling of proofing. So with that being said, let's get to it. So let me do some erasing here. Please note that for the purposes of this proof, I numbered some of the angles I knew I was going to need, and I saw a lot of people numbering them all, which I think is equally fantastic. I'm just kind of thinking ahead, where if I'm going to try to communicate to someone in a proof, it's very difficult to follow angles and try to follow angles if I'm throwing out quick three-letter combinations like QRV, VDT, SUT, TSU. But it's much easier to communicate to somebody and actually literally be able to communicate in written word if I say, well, angle 8 is congruent to angle 7, or angle 5 is congruent to angle 6. So that's a tactic a lot of people are taking and using, which I think is fantastic, and it's perfectly legal to do in proof. So before we actually get into writing the proof, let's think strategy. I need to prove these upper and lower medium-sized triangles are congruent, but honestly I don't have the information to do it right now. I do have some information right now. For example, if I take advantage of two parallel lines cut by a transversal, which I will mark in more obvious colors. If I take advantage of these two parallel lines cut by this transversal, I do know some things about the upper and lower triangles right now. Namely, I do know that angle 2 has to be congruent to angle 1, alternate interior angles. But that's not going to be enough. I don't have anything else. I need at least a side length somewhere and some more information about angles. These are the ones I'm trying to prove. Can't do anything about that. I don't know anything about 7, and I believe this is marked 8, because these lines are not parallel. So right now, I don't have anything else. So I have to kind of think about options. Okay. So what I mean about options is, well, I'm going to have to prove something to get some information. So what's that something? Well, if I can prove other triangles are congruent, that would generate a lot of information for me. For example, if I could somehow manage to prove that these two triangles are congruent. Now, I don't know how I'm going to accomplish that at this point, but we're just kind of thinking ahead. If I can manage to prove these are congruent, I would know all corresponding sides and angles are therefore congruent. So these sides, which are already marked, but also I would know these sides are congruent, and then I would know 1, 2, 3 is congruent to 1, 2, 3. That helps me out, because if my goal was to prove that the upper and lower triangles were congruent, well, look, I now have the side length I actually needed. and I'm well on my way to, say, building a second side length. Right? Now that's not my only option. What I mean is, these two yellow triangles, or ones that are currently marked yellow, aren't the only other triangles in this diagram. Let us not forget that there's actually a third set of potentially congruent triangles, which would be the upper and lower parts of this entire diagram. Now, for me, this is the one I want to take. And the reason this is the one I want to take is because I think I have at least a majority, if not all, the information I need right off the bat. So looking at the upper and lower triangles, I immediately see a reflexive piece. I immediately see another side length of both triangles. That'll be more obvious. So I see a reflective line that's shared by both the yellow and green triangles. I see a given side in both the yellow and green triangles, and then all I really need would be an angle. And I'm thinking if I could take advantage of parallel lines cut by a transversal, then I actually have an angle as well, which would be the angle formed between the parallel line and the transversal, between the parallel line and the transversal. So again, options. I just believe this one's actually easier. So that's going to be my basic tactic in this proof. I'm going to prove that the yellow triangle is congruent to the green triangle, and it seems I have side angle side to do it. And then from that, I'll generate extra information, and then that should get me enough to prove these two triangles are congruent. And if these two triangles are congruent, well, then the angles involved should be congruent as well, and that was my goal from the very beginning. Okay? So to recap, and then we'll actually start doing it, I'm going to prove the big yellow and the big green are congruent. I'm going to use that information because they're congruent to give me additional information about the smaller, or I should say medium triangles in this diagram. And once I prove they're congruent, then the angles of T and R should be congruent, which is what I was looking for in the first place. So now I've wasted 7 minutes trying to explain what I want to do. Let's do it. And again, please note that I've kind of marked my diagram in an effort to make this communication a little bit more obvious. Okay, so let's jump into it. Step 1 was to prove the big triangle is congruent. So I'm going to write this proof in a flow style just because I think it's going to lend itself well. Also because it's going to occur in multiple stages. So I'll try to annotate the stages out to the left so it's really obvious what I'm trying to do at any given point in time. So let's go. So the first thing we really have to do is what we have to really prove the big triangles are congruent. So in other words, let's go ahead and name them. Let's go big triangle top first. So QRS. Okay, so QRS, and it should be congruent to STQ. Okay, so just like our plan said before, and go ahead and rewind the video if you think you need to see that again. Was to prove by side angle side, so I'm going to set up a very familiar kind of flow style. Okay. So our first side should be QS, congruent to QS. Okay. I'm going to write the justification below our statement. So QS is congruent to QS, which is our reflective side. That should be by the reflexive property. The angles should be between them. In this case, I've marked them 3 and 4. So angle 3 should be congruent to angle 4. And again, we kind of talked about the reason previously a couple minutes ago. So rewind if you need to watch that again. But angle 3 and angle 4 should be congruent because of the alternate interior angles theorem. Notice I'm doing a lot of abbreviation, which is totally cool. EOREM. And then our last side was actually given to us. We have RS and QT. If all three of these statements are true, which we have shown they're true, that we can conclude that QRS is congruent to STQ. And that's going to be because of side angle side triangle congruence theorem. Okay. Just so it's a little bit easier to kind of separate the information, I'm going to go ahead and put these in boxes. just because this is a little more complicated than your average congruence proof. I'm not going to switch colors, so maybe it's a little bit easier to track. Okay. So what does this give us? I'm going to blow this picture back up so we have a little better idea what information we now have. We know that the upper and lower huge triangles are congruent. Well, what do we know as a result that's actually going to be useful for us? Well, if this big triangle is congruent to this bottom triangle, I know that this side is congruent to this side. So R, S, Q, T. I'm sorry, R, Q, R, and S, T. That at least gives us some extra information about our triangles, right? I don't know if that's ultimately useful, but that's going to be okay. What else do we know? Well, we know some angles as well. Namely that angle 8 should be congruent to angle 7. We already knew that 3. Now we do know this big angle here at R and this big angle here at T are also going to be congruent, but that's not going to be useful enough for these smaller triangles. So that gives us an angle. That gives us a side here. So all we really have to show is like another angle. If we know angle, we know a side, and we know one more angle, then we're in business. Now, from the very beginning of the video, I said one of the big observations we can make is I do have two parallels cut by a transversal going through the middle. So that would give us that angle 2 and angle 1 are congruent. That's alternate tier angles. I think that's going to be enough. Angle, angle, side, angle, angle, side. That's going to prove congruency. So it seems like the one piece we need to graph from our triangles is that we have two sides that are going to be congruent because the big triangles are congruent. And then these angles at 8 and 7 for the same exact reason. And it looks like we'll grab another angle from a different reason. So let's go ahead and set that up. Let's go ahead and prove that. Okay, so let's make a little side note here. So because we know that these two triangles are congruent, it gives us a lot of information, but the two pieces we actually need would be angle 7 is congruent to angle 8, and QR is congruent to TS. Okay. I'm not going to... Oh, in terms of justification, what we really have to write here is that's the definition of triangle congruence. It's actually the very first justification we used in this section, this unit. If two triangles are congruent, then all corresponding parts have to be congruent as well. So if these two triangles are congruent, corresponding parts should be as well. Now I need to go about proving that the two medium-sized triangles are congruent. So I'm going to kind of write that off to the side. So in step 2, I'm going to try to prove that triangle QRV is congruent to triangle SUT. Oh. Whoa, oversized eraser. QRV congruent. I misaligned it. So QRV STU. And we're going to go about proving that in terms of angle side. Okay, so let's go to our first angle. I'm going to go angle 1 is congruent to angle 2, and that's going to be because of alternate tier angles. The second angle will be 7 and 8, and that's going to be because of definition of triangle congruency. And then our side should be QR and TS. And that's going to be because of definition of triangle congruency. Okay. If all these things hold true, which we have now shown they do, that would show that triangle QRV is congruent to triangle STU. And that'll be because of the angle side triangle congruency. Okay. Okay, so if the two medium triangles are now congruent, all corresponding parts should be as well. So this should lead us directly to being able to say that the angle at T and the angle at R are now congruent. Hence, the proof statement, UTS, is congruent to angle VRQ. And that'll be again because of definition of triangle congruence. Okay. Okay, so to recap, what do we have to do to actually get to this final condition? Well, we have to actually first prove that the big triangles were congruent. Use the information because of congruent triangles to prove that the medium-sized triangles were congruent. And because they're congruent, then the angles that we actually wanted in the first place must be, because the triangles are involved in are congruent and that they are corresponding. Okay? So it's a multi-stage proof. In fact, you have to do a lot of things here to accomplish the final goal, but guys, that's kind of the way it is. So I hope this helped. Hope you're studying hard for that test on Monday. Something like this will definitely be on that test. You can expect a proof in which you'll have to prove triangles are congruent and use that information to do something else. So spread the word. Make sure people are watching this if they need it. Watch as many times. Ask me questions at Edmodo if you guys need to talk more about this before Monday. Monday tests suck, but that's just the way it is. Alright, thank you guys. Have a good weekend. Study hard.